E1. Our first problem is an Apollo 15, the Apollo 15 rocket. And here we're going to only look at the problem for the first several seconds, so we can neglect any loss of mass. So this is going to be a constant, the mass, we're going to neglect the little bit of mass that's coming out, because we're not going to look at the first few seconds. We want to find out how long it takes to clear the tower. It's basically clearing the tower right now. So how many seconds, in other words, the time to clear this H, say, some kind of, the tower's the H, and what's the time that goes with that. So that's the problem we're going to do. And we're given information. We're given here the weight. See, the Apollo 15 technically is like the load up here, and then this is the Saturn V rocket. So we're given here the weight of each of these. So the Saturn V rocket is 27.1 million newtons, and then the Apollo 15 spacecraft that sits on the top is light compared to that, 0.48 million newtons. So when you add them together, which is what we're going to be doing, we're going to get here 27.58 when we add them together, million. And the thrust, which gives you, by the action-reaction, gives you the force going upward, that thrust is given as 33.4 times 10 to the 6 newtons. So you're basically looking at a configuration that weighs something like 6 million pounds, 27 million newtons, and the thrust is 7.5 million pounds, 33.4 million newtons. So we go ahead and do our sketch first. I always like to do a little sketch. That's part one. Go ahead and have the rocket here, like this. And you're gonna have the rocket, move up. And then here, we want to have the force diagram. So I have the rocket there. We're gonna have the weight pulling down and the thrust, pushing up. And we have then Newton's second law. Now remember, a rocket problem does change its mass, but we're neglecting the mass that's going to come out just in the first few seconds, the Earth, to go to the moon. So for Newton's law, the force, total force, would be T going up minus W going down, and that's equal to MA. So we want to solve, in this case, for that time. So what we're going to do is find the acceleration. That's the easiest thing I can find here, since I'll have all the information here that's given. I can start plugging in. So we said that the weight is 27.58 times 10 to the 6 newtons when you add together the Saturn V and the Apollo 15. So at this point, we could solve for the mass, since the weight is mg, since I need that mass. So see, I'm given the thrust. The thrust was given as 33.4 times 10 to the 6 newtons. I got the total weight. So if I have the mass, I can then solve the acceleration. So for the mass, that's going to be the weight divided by g, which will be here the 27.58 times 10 to the 6 newtons divided by 9.8 meters per second squared. And when you work that out, you get 2.814. Remember to keep extra significant figures to round off at the end, and that's kilograms. If you want to see the kilograms cancel, remember this is kilograms times meters per second squared in dimensional analysis. So the meters per second squared is canceled and you get the kilogram. So then the acceleration, which is equal to t minus w divided by m, now I can plug in all the numbers. So I can plug in for the mass here, and then for the thrust, that's going to be the 33, this here, the 33.4 million newtons. And then this is the weight, which will go in there. So when we plug all those in with the calculator, you're going to get A is 2.068 meters per second squared, 2.07 meters per second squared. So it's about a fifth G. That'd be like the G-force you experienced, the astronauts would be experiencing at that time. So then to find this height, since we're talking about here a height to clear of the tower, we're going to use y is y naught plus v naught t plus 1/2 at squared. And I know that it starts from rest, so y naught is 0, and then v naught is 0. And this is going to be the height of the tower, that y. I can just leave it as y. That is fine. So y equals 1/2 at squared. 2y divided by a is t squared. You know, put the 2 over there and divide by a. And that gives us t as the square root 2y over a. Now they give us the tower height. That was given in the problem. And that was given as 136 meters. So y was given in the problem. And when you're doing your sketch, you know, it's good to include all the information, all the given at that point. So here, if I was doing this for a homework problem, I would, you know, make sure all the given is up front with the picture here. You want to include, you know, the given information there. So if we then divide by the 2.07 here, work this out, you get 11 seconds. And I found on YouTube, they had a video of the rocket going off, and I timed it, and it was like 11 seconds. It was awesome. Like that's the answer. So you can Google that on YouTube and find that. So that's reflecting a little bit on my answer. Is it reasonable? Do I have the right amount of significant figures? I mean, you could say 10 seconds here if you want, but I mean, you know, here we are neglecting, you know, some of that mass going off. So I would feel probably more comfortable just saying 10 seconds, report it as 10 seconds, and that's it.